If this kind of curves are given, then in that case there are some proper substitution which can be used, and using those substitutions calculation will be a lot easier. Okay, of course this method is valid, but whenever you see one of these, accordingly we have to decide the parametric equations for this curve. Say I'll start for the line. That again, this is something that we have seen. So line, just a minute. So for line, a point A is x1, y1, z1, B is x2, y2, z2. A line joining these 2 points will have the parametric equation x is equal to x1 plus x2 minus x1t, y is equal to y1 plus y2 minus y1t, z is equal to z1 plus z2 minus z1t. These are the substitutions to be used, and t in this case will be running from t equal to 0 to t is equal to 1. We have discussed this. For t equal to 0, you can see that the value of x will become x1. If you put t equal to 1, then the point that you will get is equal to x2. It means that it is representing a line which starts from the point A and ends at the point B. For the circle, the parametric equation x is equal to a cos t, y is equal to a sine t, where a is the radius. Okay, and t is running from 0 to 2 pi, but 0 to 2 pi is for complete circle. Okay, if I have a semicircle, just the upper part of the circle, this much, then at this point t is equal to 0, and at this point t is equal to pi. So if we have a semicircle, then t is running from 0 to t is equal to pi. If we just have this part of the circle, then t is running from minus pi by 2 to t equal to pi by 2. So depending on which part of the circle is asked, accordingly I will have to decide the value of t. The last one, ellipse. Ellipse. The equation of ellipse, let me just revise this. Again, this is something that you have seen in your diploma. The equation of ellipse is x square upon a square plus y square upon b square equal to 1. This is the equation of ellipse. Now, in this, the parametric equation of this ellipse is given by x is equal to a cos t, y is equal to b sine t. What is the significance of this a and b? Look, whatever is the denominator of x, that has to be here. Denominator of y square has to be here. Again, the idea is same. The value of t is equal to 0 to 2 pi will be for complete ellipse. The value from 0 to t equal to pi will be for the ellipse in the upper quadrant, which means this one. Minus pi by 2 to plus pi by 2 will be for the ellipse which is in the right hand side quadrants. Okay, these are the things that we have seen yesterday. So today we'll start with some of the examples in which this parametric equation is being used. Example, evaluate integral over c f bar dot dr bar for f bar is equal to 3x square I bar plus 2xz minus y j bar plus z k bar along the straight line joining 0 0 0 and 2 1 3. Okay, so first of all, integral over c f bar dot dr bar. Do this dot product and that will be integral over c 3x square dx plus 2xz minus y dy plus z dz. Now use the parametric equation of straight line. Once you see the straight line, you should go to the parametric equation of a straight line. This is x1, y1, z1. This is x2, y2, z2. So x is to be substituted as 0 plus 2 minus 0 into t. Look, I'm using just what I have written in the previous page. So y1 plus 1 minus 0 t. Z is equal to 0 plus 3 minus 0 t. So x is equal to 2t, y is equal to t, z is equal to 3t. So dx will be running, dx is equal to 2 times dt, dy is equal to dt, and dz is equal to 3 times dt. What was the limit for the t in this case? T is running from 0 to t is equal to 1. Even this limit for the straight line joining 2 points is given. So let's substitute all of these. Z is equal to 0 plus 3 minus 0 t. So integral over c f bar dot dr bar is equal to integral 0 to 1. The value is 3x square. So 3 times 2t square dt. 2 dt, sorry. Look at the calculations very carefully. Plus 2 times 2t 3t minus t. What is dy? Dy is dt plus z, which is 3t. dz is equal to 3 times dt. Now this is equal to integral 0 to 1. This will be 4, 12, 24 t cube plus, okay, let me just write it down explicitly. Bracket 4, 12 t square minus t dt plus 9t dt. So this is equal to integral 0 to 1 24 t cube plus 12 t square minus t plus 9t, which is plus 8t.
Sir, it will be t square.
Which one?
The first term.
There's t square.
Yes.
Mm, yes, sorry. 24 t square. 24 t square. So this will be 24 and 12, 36. And 36 t square plus 80 dt. Fine. So the integration formula of integration used here, x raised to n dx is equal to x raised to n plus 1 upon n plus 1. So what is the integration here? 36 t square का integration t cube by 3 plus 8. Integration of t will be t square by 2. Limits from 0 to 1. So the answer is 60. No problem. So let's go ahead. Find the work done in moving particle once around the ellipse. X square upon 25 plus y square upon 16 is equal to 1, comma z is equal to 0. Under the field, under the field of force, F bar is equal to 2x minus y plus z, I bar plus x plus y minus z square, j bar plus 3x minus 2y plus 4z, k bar is the field conservative. Now what we have is we have ellipse and it is a complete ellipse. So the substitution from the remark is to be x is equal to a cos t, y is equal to b sin t. So integral over the curve f bar dot dr bar is equal to integral over c. F bar dot dr bar will become 2x minus y plus z dx plus x plus y minus z square dy plus 3x minus 2y plus 4z dz. Let's put the substitution. What is the value of a? I said that whatever is this denominator of x square, that is a square. So a is going to be 5. and denominator y square is b square. This is your a square and this is your b square. So a is equal to 5 and b is equal to 4. So put x is equal to 5 cos t, y is equal to 4 sin t. What is dx? Dx is equal to minus 5 sin t dt, and dy is equal to 4 cos t dt. And t is running from 0 to t is equal to 2 pi. Okay, let me just write it down below this so that the space can be utilized later. So this is equal to integral 0 to 2 pi by the 10 cos t minus 4 sin t. Note that the value of z is already given 0. So z is equal to 0. So dz will be equal to 0. 10 cos t minus 4 sin t dx is nothing but minus 5 sin t dt plus in the second bracket 5 cos t plus 4 sin t dy is 4 cos t dt. This can be further simplified 0 to 2 pi minus 50 cos t sin t. It will be plus 20 sin square t dt plus 20 cos square t plus 16 sin t cos t dt. So I can take dt outside. 20 common, sin square t plus cos square t will become 1 minus 50 and there is plus 16. So integral 0 to 2 pi minus 50 plus 16, that is going to be minus 34 minus 34 sin t cos t. And from these two terms I can take 20 common, sin square plus cos square will become 1. So plus 20 dt. So this is minus 34 integral 0 to 2 pi sin t cos t dt plus 20 t from 0 to is 20 0 to 2 pi. So in this example what I can do is I can put sin t as t. Sorry, let me just do it somewhere else. So you can check this on a rough page. So what I will do is I'll put sine of t as say x. So cos t dt will become dx. X is equal to 0, t is equal to 0, then x will become 0. I'll do it here. Rub this question and do the calculation here. Okay, so what I was doing, put sine of t is equal to x. So cos t dt is equal to dx. T is equal to 0, then x equal to 0. If t is equal to 2 pi, then still x is 0. So if you put this 0 to 0, whatever the answer is, so x dx, this is what it is going to be, an integration x square by 2, 0 to 0. Actually, this is not the correct procedure, but still roughly you can see that the answer is turning out to be 0. But there is a chapter which is called the reduction formula. You may have seen it in your bridge course. So finally, what we get is minus 34 into 0 plus 20 into 2 pi. So this is 40 pi, the correct answer. Now, there is another question which says that is this field the conservative? So, conservative vector field, we have seen that it is a field where path, so work done is independent of the path. So, I have the point A and I have point B. So I'm going from A to B. I'll have some work done. From these two paths, P1 and P2, any two paths will have the same work done. Okay, so now You're going from A to B, then you're coming from B to A. Okay, so the directions, this work done will get cancelled out with this work done. So as we are working with a complete ellipse, so it starts from this point, go to this point, and again come to this point. So work done for a conservative vector field, complete for a complete ellipse, that has to be zero. If this answer turned out to be zero, then I can say that yes, it is conservative vector field. As this work done is non-zero, so the vector field is not conservative. So I'll make the statement here as the work done is non-zero. Vector field is not conservative. Next example, if f bar is equal to 2xy plus 3z square I bar plus x square plus 4yz j bar plus 2y square plus 6xz k bar. Evaluate integral over c f bar dot dr bar, where c is the curve x is equal to t, y is equal to t square, z is equal to t cube. Joining the points 0, 0, 0 and 1, 1, 1. Do it. Within 2 minutes, this has to be solved. Check it if you can do it, or else I'll go to the next topic. Okay, anyone? Yash, Shantanu,
Substituting, sir. Yes.
substituting. Okay, do it. Okay, so write down the final answer. That is 6. So you can try it later. Give the new theorem. Theorem is called Green's lemma. So the theorem states that consider a closed curve C enclosing an area capital A. Let u of x comma y comma v of x comma y and their first partial derivatives, first partials lava u beta by x lava u beta by y lava v beta by x lava v beta by y be continuous and single valued and single valued over the region bounded by C. Then line integral over C u dx plus v dy is equal to double integral over a partial derivative of v with respect to x minus u with respect to y dx dy. Whatever is written above, please ignore it. What we have to concentrate on is this equation. What this equation or what this states. So you have a closed curve. Okay, this is the closed curve around on which you are taking the line integral, and there is the area. Since it is closed curve, there has to be an area which is bounded by this curve. So the Green's lemma states that the line integral over this curve u dx plus v dy is actually equal to double integration over this area A partial derivative of v with respect to x minus partial derivative of u with respect to y dx dy. Okay, so this is very important because lot of line integral problems can be actually converted to the double integral and we could solve it easily. Okay, and one more thing here, note that the orientation of the curve is anti-clockwise. Okay, so if this is in the clockwise direction, there will be some change in this equation. So what we will stick to is we'll stick to the anti-clockwise rotation. Okay, please memorize this equation, take a screenshot of it or whatever, however means you want to remember, but this has to be in your mind. Okay. Now, there is this concept of double integral. Let me just talk about this. I'll give you a rough idea about this double integral. So when I am integrating, so I have say x square plus y square dx dy, and limits are say 0 to 2 and 3 to 4. So first of all, we'll solve this integration. So dx is written first. So integrate with respect to x. Just this term with respect to x. In this case, what we have to do is integrate with respect to x and treat y as constant. Treat y as constant. Whatever is written this here, whatever is written first, if it was dy, then I would have integrated with respect to y and treated x as constant. Now, as I'm integrating with respect to x, I will be treating y as constant, just like partial derivatives. Right now, when I just have to evaluate the integral. Okay. So now, if I evaluate this that will be x cube by 3 plus y is constant, y square will be constant, and integration of constant is constant into x, then dy. But before that, there is the limit from 3 to 4. So integration 0 to 2, can put the upper limit 4 cube by 3 plus y square into 4 minus, then you put the lower limit, that will be 3 square plus y square into 3 dy. So now what we have to do is we need to integrate with respect to y. So that will be 4 cube 64 by 3 times y. 4y square plus 3y square, that will be 7. Y square integration is y cube by 3 minus 9y. Limits from 0 to 2. So when you put the upper limit, 64 by 3 into 2 plus 7 by 3 into 2 cube, which is 8, minus 9 into 2, 18. So whatever the final answer that you get here. So just understand this complete procedure, how to find the integration when these limits are given to you. So if there is this dx, then what you do is you integrate with respect to x and treat y as constant. Then you put the limits, then you just have one variable y, then integrate with respect to y, you get the answer. Now the next thing is about giving the limits. Okay, so whatever area is specified while solving example, we'll see how to give the limits in this case. Because it will be very much difficult if you directly go for understanding the abstract things. So I'll take an example now and I'll explain how we give the limits. Example, verify Green's theorem for the field f bar x square I bar plus xy j bar over the region enclosed by y equal to x square and the line y equal to x. Let me just write down the statement first of all. Under the Green's theorem say you take the line integral over the closed curve C f bar dot dr bar. In that case, this will be actually equal to area over double integral over the area enclosed by this closed curve into, in terms of f bar I am writing f2 with respect to x minus f1 with respect to y dx dy. Okay, what this is what I'm making that theorem. I mean aligning it with the things that I have been using so far. What I'm writing f bar as f1 I bar plus f2 j bar. This is how I'm writing f bar throughout the chapter. So we have aligned the Green's theorem with that. So this is what I have to verify. So first thing that I will have to do is let's draw this curve. You have x-axis, you have y-axis. y equal to x square is a parabola like this. If you don't know how it is, you can simply put some of the values. You put x equal to 0, you will get y equal to 0. You put x equal to 1, you will get y equal to 1. You put minus 1, then you will get plus 1. You plot the points and join them. That is the easiest way how you can draw any curve. Then y equal to x. So you need to collect all the points where you have the value of y is equal to value of x. So this is the area. Take the orientation anti-clockwise. So in this curve, there are two lines, paths actually. I'll call this 0 and I'll call this capital A. Sorry, um, take this point P. So if I want to find the line integral, so what I will have to do is, so our curve C is the first curve C1 and C2. So we will have to go use the curve C1 first of all to go from the point origin to the point P. Then the curve 2 will take us from P to O. So that will become my closed curve. Okay. So the line integral over C f bar dot dr bar will actually be equal to the line integral over C1 f bar dot dr bar plus line integral over C2 f bar dot dr bar. So that will go get the complete curve. So we'll call this I1 and we'll call this I2. So how we will get I1 here? So I1 is equal to integral x square dx plus xy dy integral over the curve C. So C1, what is the curve? This curve is y equal to x square, right? So if I put x is equal to t, put x is equal to t, what we get y will become t square on this curve. What is the value of t? T is going from t is actually equal to x. X is changing from this point at which x is 0. X is equal to 0 to x is equal to 1 at that case. So both will intersect at that point 1 comma 1. So t is running from 0 to t is equal to 1 because this point is 0 comma 0 and this will be 1 comma 1. Put these values 0 to 1. What will be dx? Dx will be equal to dt. Dy is equal to 2t dt. So t square dt plus t into t square 2t dt. So this is integral 0 to 1 t square plus t 2 t raised to 4 t square plus 2 t raised to 4 dt. What's the answer here? T cube by 3 plus 2 by 5 t raised to 5 limits from 0 to 1. So 1 by 3 plus 2 by 5, which is 11 by 15. Now, is everyone clear up to this? If you have any difficulties, you can ask, or I will go for I2 now. Fine. Now, if you're writing this, write it down. Wait for a minute. Now I2. Now I2 is equal to integral over C2 x square dx plus xy dy. What is our I2? I2 is this curve, okay, which is the line y equal to x. So if we put x is equal to t, you'll get y is also equal to t. What is the value of x going from this point P to the point origin? At the point P, the value of x is 1, and this at this origin, the value of x is 0. So t is running from 1 to t equal to 0. Dx will become dt, dy will also become dt. So this is equal to integration 1 to 0 t square dt plus t square dt. So this is 2 times t cube by 3 1 to 0. So this is 2 in bracket minus 1 by 3. So this is minus 2 by 3. नहीं 40 minutes maximum. So fine. Integral over C. I'll rub this. Can we rub this? Hence. Hence. मैंने साइलर भेजा है आपको. Integral over C. तो साइलर असाइन करो खाली वो हम f bar dot dr bar is equal to. हम असाइनमेंट देते हैं उनको और वो सबमिट करेंगे अपना अपना करके. हाँ कर 11 by 15 minus 2 by 3. I1. This is I1. This is I2. वो सबमिट करेंगे. So the answer for this is 1 by 15. और एक पता करना था आपके बैच में जिन लोगों ने सबमिशन नहीं किया कंटिन्यूस एब्सेंट है वो नंबर्स मुझे चाहिए कोई इन्फॉर्म करना है. Fine. So this is the line integral. Now we have to go for the double integral. That will go after the break of 10 minutes. Yes. Any problem in this?
No, sir.